6 missiles, 100 meters per second squared acceleration, 5 kilometers reach, engineered restraint. Truman's 1950s decision to pursue thermonuclear weapons, engineered escalation. Those timelines do not rhyme, and that's exactly the point of this video. We'll confirm how the Viper's compact, reloadable cell invites experimentation while the real hydrogen bomb, validated through IVY and CASTLE, forced ethics committees and range evacuations. If you think hydrogen means the same thing in both worlds, the next few minutes will undo that assumption with numbers, procedures, and consequences that never spawn from a projector block. Before we move on, please take a moment to subscribe to the channel and like the video. How does a weapon labeled hydrogen teach restraint? It does it by tying every shot to a checklist, not a dopamine hit. The Viper asks for process, and once you accept that premise, the rest of the design choices start to make sense. The hardware is small and specific. A 7x5x3 block footprint, 6 missiles. A single guided cell that reloads itself and hands off control through a pre-configured designation turret. It runs WHAM and LAMP for steering and target logic. So guidance is not an afterthought bolted onto a warhead. It is the point of the cell. But it refuses to scale the way typical game weapons do. Add a second cell on the same hull and the guidance scripts step on each other. You lose coherence and, with it, the promise of more is better. That friction is intentional in effect, if not in sentiment. It suppresses the instinct to stack launchers and chase power creep. So you end up treating the Viper like a lab test bench. 1 cell per ship. 1 shot to validate lock quality, separation, and terminal geometry. You do not run a battery. You run a controlled trial and measure what the missile did in that window. It turns a gun deck into a flight test pad, and it makes the crew fly the procedure, not the impulse. On performance, the numbers drive the behavior. Range near 5 kilometers. Acceleration near 100 meters per second squared. Those figures put the intercept inside a short timeline, where the motor hauls the missile to useful energy fast, and then everything depends on whether the lock holds and line of sight stays clean. You cannot hope the target obliges. You maintain discipline, or you waste a shot. Launch control splits into 3 paradigms, and they read like range procedures. Camera lock uses LiDAR through a ship camera. You place the reticle, establish the return, and commit. Turret-directed fires through the pre-configured turret, which offloads tracking to a stabilized mount. Beam ride steers along your line of sight, so the missile rides the vector you draw with your aim. None of these encourage saturation. They reward stable designation and timing. The community reports reinforce that this is an experimental platform, not a plug-and-play rack. Users have had to toggle stockpile mode on the missile tanks after reload, often with a timer block, so propellant state aligns before launch. Others found connector strength settings on the mount, and missile could bind separation and had to be corrected. There are notes on hang-ups in gravity that improved when guidance delay was increased, giving the missile space to clear the cell. Some crews leave silo hatches open in combat to reduce misfire odds. These are test stand adjustments by another name. By this point, the branding matters. Viper signals a fast, agile strike. But the label that keeps confusing people is hydrogen. In this context, hydrogen drives the missile. It does not scale its yield. The resource buys mobility and endurance for the round. It is fuel, not a multiplier. So the mini payoff is simple. The Viper name sells a reusable precision test platform. It's a 6-shot cell that enforces a cadence. Lock, verify, fire, review. Hydrogen here powers the missile's transit and reload logic. It does not turn the device into a super bomb. So with that anticlimax, we can now contrast this tight sandbox with the century's largest step change in destructive engineering, where hydrogen meant staged physics packages, radiation coupling, and yields that forced governments to redraw maps and evacuation plans. If hydrogen in the Viper is a propellant ledger, what did the real devices require to earn that word? They demanded an architecture, not a tank setting. The work began with a two-stage configuration in which a fission primary produced X-rays that were deliberately channeled into a separate package, compressing a fusion secondary containing deuterium tritium or lithium deuteride. Staging turned radiation into a tool. Compression and heating were the trigger conditions, and when met, the secondary burned in a regime that no single fission core could approach. The policy track ran in parallel and in tension. The General Advisory Committee warned that the superbomb led to effects that reached past any military target. They wrote that, by its very nature, it cannot be confined to a military objective, but becomes a weapon which in practical effect is almost one of genocide. In January 1950, President Truman approved acceleration anyway. So the design debate and the ethics debate diverged, and strategies set the schedule. Think of staging as a relay. The primary hands radiation to the secondary through a channel, and the secondary returns output on a scale that makes any fission-only device look like a warm-up run. The geometry and materials allowed that handoff to occur fast enough and symmetrically enough to drive the fusion stage to full yield. It was therefore a procedural solution to a physics bottleneck. Early tests established feasibility in steps. Operation Greenhouse in 1951 included the George shot, which indicated that a fission burst could light thermonuclear fuel and validate the radiation implosion concept. That was utility, not yet a weapon. It gave the theorists numbers and gave the program a direction. Operation Ivy followed in November 1952 with the Mike device. It produced a yield on the order of 10 megatons, and it did so using liquid deuterium. Cryogenics made the package large and unwieldy, and it proved the concept with a refrigeration plant attached. The lesson was clear. Staging worked, but deployment required a solid, storable fuel. That arrived with Operation Castle in 1954. The Bravo shot used lithium deuteride and produced about 15 megatons. The result demonstrated weaponized practicality and a different cost column. Fallout went far beyond the instrument grid. Downwind atolls received contamination, and a Japanese fishing vessel, the Lucky Dragon, was exposed. The unexpected participation of lithium-7 in the reactions drove yield higher and pushed radioactive debris over a wider area than planned. By this point, the physics package had become a policy instrument. Scale shifts mattered. When yields jump from kilotons to multi-megatons, the role moves from tactical interdiction to continent-scale signaling. This is not a module you bolt into a launcher. It is a strategic statement you can only make with national infrastructure behind it. Production and delivery caught up quickly. The Mark 17 and Mark 24 were among the first mass-produced hydrogen bombs deployed in 1954, differing mainly in their primaries and retired by 1957. The same push to make staged devices practical drove later miniaturization. And with intercontinental ballistic missiles, the arms race shifted into a delivery problem rather than a yield problem. So we now have two hydrogens with the same label and opposite consequences. In the Viper, hydrogen buys thrust, cycle time, and logistics for a precision tool. In real thermonuclear development, hydrogen isotopes, configured in a staged design, multiply yield by orders of magnitude and turn targeting into geopolitics. In any case, the label is shared and the outcomes are incompatible, which takes us to the responsibility problem. What you owe the shot caller when guidance is easy and consequences are not. Hydrogen is doing two jobs in our story, and the bookkeeping is not the same. In a game, it meters thrust and reload tempo. In state arsenals, it drives an escalator with no ceiling. Conflating them erases the cost ledger that defines the real device and why committees objected. Treat the Viper like a range event. Name your assumptions, cap your shot count, and read at least one primary account from IVY or CASTLE before calling anything clean. We can now move on to guidance itself, how scripts approximate a fire control loop under jamming and delay, and where those approximations fail under pressure.